Alright, this is a pencast for problem number 2.4.14. You can check it out online. The prompt asks, a bicycle initially at rest accelerates for t equals 18 seconds at a rate of a equals 2.6 meters per second squared. And the first prompt is going to ask you to solve numerically for the distance of the bicycle that it travels during this period. So the first step, of course, as you all know, is to draw a diagram. So I'm going to draw a bike. It's my bike. And it's initially at rest. So x equals 0 meters and v naught equals 0 meters per second. Because again, the bicycle is at rest. We're going to draw the track that the bike is traveling on. And we're going to label our coordinate system. Positive x is going to point in the rightward direction. And this doesn't really matter, but y is going to point upwards. So I'm using a normal coordinate system. Alright, so the bicycle is at rest. And looks like it accelerates for 18 seconds at a rate of a, I'll just label a, equals 2.6 meters per second squared. And t equals 18 seconds. Alright, so once again, problem A is going to ask you to solve numerically for the distance that d traveled. We're going to start off by writing our knowns and unknowns. So we got x naught. We know what x naught is, 0 meters, because once again the bike is at rest. V naught equals 0 meters per second, because once again the bike is still at rest. We're solving for the final distance, so we don't know what the final distance is. We know what time is. Time is 18 seconds. That is given in the problem. And looks like we don't know what the final velocity is. So put a question mark over there. And it looks like we do know what acceleration is in the x direction. The acceleration, the problem says, is 2.6 meters per second squared. That should be squared. 2.6 meters per second squared. All right. So now we have two variables. So it looks like we can use one of our infamous kinematics equation in one dimension. And the one I'm going to be using is x equals x naught plus v naught t plus 1/2 at squared. And it's asking us to solve numerically, so we can just solve for x by plugging in stuff. Well, we're going to cross some stuff first. We know x naught is 0, so boom. We know v naught is also 0, so boom. So we're left with just x equals 1/2 at squared. We know a, we know t. Once again, a is 2.6 meters per second squared. And t, the problem gives us 18 seconds. Pretty simple. And if you do the math, you type it in your calculator, you should get x equals 421.2 meters. That is the answer for part A. Pretty simple. Alright, looks like part B is going to ask you to find an expression to find the final velocity over there. And it's going to ask you to solve numerically, or not numerically, but it's going to ask you to solve or find an expression first, right? So I'll put B over here, part B. So part B is asking you to find an expression for final velocity. So it looks like I'm going to be using v final equals v naught plus at to find the expression. We're trying to find v final. We know v naught is just 0, so we can cross that out. So in an expression form, v final equals a times t. That's it. That is all you have to do. Alright, part C. Part C is asking you to plug stuff in to find the final speed, so that's pretty simple. V final equals acceleration. You already know what your acceleration is again, because the problem gave it to you. 2.6 meters per second squared times t. Looks like they also gave you t, once again, 18 seconds. If you plug everything in and put it into your calculator, you should get v final equals 46.8 meters per second. And that, folks, is the final velocity. Fairly simple problem. And yeah, that's about it. Thanks for watching. Please subscribe.